Look at this visualization of a multi-agent AI system. It's a seductive idea, throwing 10 or 20 language models into a virtual room, hoping that a vastly superior intelligence will naturally materialize. The assumption is that linking multiple AI agents automatically generates a smarter system. But this animated diagram shows what's actually happening under the hood. You might assign 3 different job titles, like CEO, developer, and tester, to 3 different agents, but they all pull from the exact same data source, use the same context windows, and rely on the same foundational model. This is called agent theater. Instead of multiplying the system's IQ, you are simply giving one model 3 different hats. It hallucinates a corporate organizational chart while generating redundant outputs, burning through your compute budget without actually advancing the work. This brings us to a strict rule of systems engineering. If a single AI agent can hold the necessary context and access the required tools, it must own the task entirely. Forcing 2 agents to collaborate introduces a heavy tool known as the coordination tax. Every single time a handoff occurs, the system suffers increased latency, a spike in token costs, and a sharp drop in fidelity. Think about the mechanics of that handoff. To pass information, the first agent must compress its internal state and generate a natural language summary for the second agent. Nuance and accuracy are physically stripped away during that translation. Without a strict operational reason, these extra agents add complexity that directly degrades both system speed and reliability. So, at what precise operational breaking point does a single AI agent actually require a specialized team to survive? Imagine an enterprise workflow where an AI needs to query a highly secure internal database containing customer financial records, and then format that data into a public-facing email marketing campaign. Granting one single agent global access to both your secure database and an external publishing tool creates a massive security vulnerability. The system drafting the email cannot be allowed to execute arbitrary queries on sensitive records. A central orchestrator evaluates the request, explicitly denying the marketing node database access. Instead, it routes the query to a specialist agent with isolated permissions. The specialist extracts and sanitizes the data. Only that clean package is pushed back and passed to the drafter. True multi-agent escalation is driven strictly by these exact security requirements and hard tool boundaries, never by a desire to simulate human collaboration. Once you have escalated the system and isolated your specialists, you have to define exactly how they interact with each other. A common approach is the conversational fabric, where developers place the agents in a virtual conference room and allow them to communicate through free-form, unstructured natural language chat. Look at the destabilization in this loop. Because underlying language models are statistically tuned to be helpful and agreeable, they often get stuck in endless cycles of polite, useless agreement, burning through compute cycles without ever reaching a solution. The engineering solution is the role-based pipeline. In this architecture, free-form natural language conversation is entirely banned from inter-agent communication. This diagram illustrates what happens instead. Agents exchange formally structured deliverables, like JSON schemas, a standard text format for data. The work only moves forward if it matches the required format perfectly, passing through a strict validation checkpoint to the next node. Replacing unstructured chatter with deterministic, verifiable artifact handoffs is the only way a developer can maintain absolute control over a complex AI pipeline. This structure makes it possible to prioritize a critical engineering requirement: failure localization. When a free-form, chat-based AI system hallucinates an answer, finding the origin of that error is a nightmare. You have to manually read through thousands of lines of black box chat logs just to figure out which agent introduced the bad assumption. But in a rigid, artifact-driven pipeline like the one shown here, debugging is trivial. An engineer can instantly inspect the data packet at each stage, automatically isolating the exact node that failed. Understanding how to structure these pipelines reveals a much larger truth about what this technology means for the future of the human workforce. There is a widespread myth that autonomous multi-agent networks will eventually operate completely in the dark, rendering human workers obsolete. This composition shows the reality. As the intermediate steps of work, the coding, the drafting, the data extraction, become automated, the human role forcibly evolves from content creator to system architect. The human mandate is to act as a mandatory routing node, engineered directly into the workflow, to handle the complex policy judgments and final approvals that cannot be safely delegated to an algorithm. By engineering humans into the pipeline as mandatory routing nodes, we shift the workforce's primary value toward policy judgment and the rigorous evaluation of machine-generated artifacts.